Swiss company with a very powerful brand and a global presence. We employ over 12,000 people in 40 countries, and we operate out of 35 manufacturing plants. We have a reputation within the industry, strong reputation, for premium quality and very much through innovation and innovative product design. Within the UK, our head office is just outside of Warwick, literally just off the M40. You see there a picture of our hydraulic tower, which is great to send installers up to. All the pipework is see-through, and we can actually run coloured water through it, so you can actually physically see the implications of bad plumbing practice. We also have a hands-on training academy, which is great because if people haven't installed our product before, they can come and spend the day up in Warwick and actually learn to do it properly. We will train them at our head office. And we also have a fully equipped showroom, which basically contains all of our products, including sanitary ware. We invest in 10 technology areas, but primarily the whole ethos of Geberit is around water saving and sustainability. So every product tweak and regeneration that happens as we move forward with product design is designed to deliver less and less water as we go through. And out of those 10 areas, obviously the one that's really important to us today for this discussion is the acoustics. And to that end, our head office it's just outside of Zurich in Switzerland. We have an acoustic lab, which is a unique thing within our industry. It's 2 buildings, and they are totally decoupled from each other, as well as 3 floors, which are decoupled from each other. We have an anechoic chamber there, which is truly silent. It's probably the only place in the universe that is truly silent. And we employ our own acousticians who work for Geberit and with Geberit to design product that is as acoustically optimized as possible. So, moving on to the next section, the dictionary definition of noise is unwanted sound. But sound is a very, very subjective thing. So what I listen to and I might think is absolutely fantastic, you might listen to and think it's absolutely appalling. So it is a very, very subjective thing. But the one thing that is not very subjective, recently Geberit sponsored a YouGov survey, and the results were actually quite surprising. 51% of people said that they had unwanted sound and noise had a very negative impact on their well-being. 35% said that they were regularly affected by bathroom noise within their own home and also neighbors' homes. And 33% of the people who answered said that they had been disturbed by wastewater noise in hotels. And I can vouch for that. It's happened to me. You can hear toilets flushing in the middle of the night, and it does disturb your sleep. So why do we hear, and what do we hear? So sound is generated by something, and it creates a wave, and that wave travels through the air, and eventually it reaches our eardrum, and that's what we hear. Now, if you were in a factory environment, for an example, and you were exposed to in excess of 85 decibels for anything more than 8 hours a day, you would have signs like that around the factory, and your employers would be absolutely made to provide you with ear protection. That would be just the state of things in that particular place of work. Now, I mentioned earlier an anechoic chamber, which is where there is no sound, and it's actually quite disconcerting. If you ever get the opportunity to go into one, please do. You can actually almost hear the blood moving around your body. A little bit disconcerting, but interesting. We think of our bedrooms as being quite quiet, you would think, but no, there's actually 20 decibels in your bedroom while you're asleep, just through various phones. You use your phone as an alarm. It's generating noise. A library, we think of that generally as a very quiet place as well. No, 40 decibels in a library. So we've got this ambient sound all around us. And if you look up near the top on the right-hand side, you'll see in the orange section 100 and 110, and that's a pneumatic drill, somebody drilling up a pavement as you walk past them. And the 110 would be a rock concert, okay? Now, obviously, your hearing can be damaged, and it can be damaged quite easily. So if you think of the 85 decibel threshold there that we were talking about, and the earmuffs, University College London, about 6 months ago, did a survey into 4 of the oldest tube lines in London. And they discovered that one of them in particular, which shall remain nameless, was generating 110 decibels in certain parts of that journey. And what they then did was they said that most people would take a 20-minute tube ride to work and a 20-minute tube ride home. That would be the norm, and they would do that every day. And their recommendation at the end of this study and at the end of their findings was that they recommended, if you do that journey, 20 minutes there, 20 minutes back, and you do that every day as part of your journey to work, they recommended earplugs so that you could protect your hearing, which is quite an extraordinary fact, really. So if we put how we get to hear the sound into some context as well. So you're going to have something making the sound, and you've got this wave traveling along, and depending on what it bumps into or hits or comes into contact with it before it hits your eardrum, some of it is going to be absorbed. We are great absorbers as people, so the more people you pack in a room, the better the acoustics generally are going to be. Theatres, good example of that. Some of the sound's going to be absorbed. Other parts of the sound are going to go through things and end up somewhere else, maybe a room next door, for example, and other bits of the sound wave are going to be reflected, so they're going to bounce off. And that will particularly apply to hard surfaces, okay? So things like glass and hard wooden tables. I know I've eaten in restaurants where I can barely hear the person across the table from me, and that's purely because all the surfaces are hard in the space. So any material that is designed to be a sound absorber, okay, to help. You've got sound absorption and reverberation, and they are the two opposing sides of one coin. So the more sound is absorbed, the less reverberation you have, and the less reverberation you have, that means more sound is being absorbed. And that is expressed as a little alpha symbol. And on any of these products, you will see a little alpha equals, and it'll be a value between 0 and 1. So for example, if you see a product that is alpha equals 0.9, you know that it's quite an efficient sound absorber. And on the other side of that scale, if you see a coefficient alpha equals 0.5, it's not being very efficient as an absorber at all. So you need to look at the balance of that in order to get the sound absorption versus the reverberation good for a space. And that is something that's very difficult to correct retrospectively after you've actually got it in place. So what do we hear and how do we hear it? That blue line, well, I'll start off with the axes. So up the left-hand side there, you've got SPL, which stands for sound pressure level, and that is measured in decibels. And in layman's terms, that would be volume, okay? Along the bottom, you've got frequency, which is measured in hertz, and in layman's terms, that would be pitch. So is it a high pitch or a low pitch? The blue line that's going down there is basically the threshold of perfect human hearing. So as we get older, the top frequencies start to fall away, and that's why older people sometimes have difficulty in a party environment, because there's so much ambient noise they can't actually pick out one voice because of that top frequency. Cocktail party effect, it's called. But you can see there that a sound or a noise, depending on your viewpoint, a very low pitch, so somewhere between 0 and 50 hertz, has to be generated at a very high sound pressure level in order for us to hear it. And as the frequency increases, so the sound pressure level can decrease until it reaches an optimum of around about 3,000 hertz. And that is the optimum hearing for us as humans without any sort of hearing defect, to put it another way. Now, your dog or your cat is going to be hearing in excess of 45 kilohertz, okay? So it's way, way more than what we can hear as humans, which is why sometimes you'll see people walking in a field with a dog, and the dog will suddenly come bounding back over nowhere because the owner's blown a whistle. We don't hear the whistle, but the dog does, okay? So I'm going to put this into a little bit of context now, and we'll have a look at what the sounds actually sound like, okay? Just to qualify here, all of these sounds have been recorded at exactly the same sound pressure level, so the deeper frequency ones are going to be harder to hear than the higher frequency ones, okay? So I'm not hearing anything coming back my way. You hearing something? Oh, sorry. Let's try that one again. Okay. So that was 100. Okay, so now we're going up to 500. Now we're going to double that. Now it possibly starts getting a bit painful, okay? Okay. Okay. Now, if you're between 19 and 25, you'll probably hear this perfectly, okay? Those of us that are older than that, you're not going to hear some of these, okay? Just a word of warning in advance. Yeah. Yeah. I can't hear this one at all. No? Okay. So to move on with that sort of concept and now actually associate those frequencies and that sound pressure level with actual things, okay, like we had on that chart earlier on, I'll start off with some of the louder ones and we'll get quieter. So if you were standing at the end of a runway and a jet took off over your head, this is pretty much what you'd hear. So that's 130. Car horn. That's 110. Bearing in mind the tube story earlier on, 110, okay? Motorway traffic. This is quite shocking, actually. I was surprised by that one. Electric toothbrush. That's loud. You don't realize. Here's our library. Your fridge. Rustling leaves in a forest. Can you hear that one? Yeah. And if you pop over to our stand, which is just next door, you'll be able to look at some of the products as a holistic whole, which can produce levels that are lower than the forest in terms of wastewater. Okay? You'll see why as well. We'll have a look at that in a minute. So let's move on to standards and testing and regulations and the like. So in the UK, we work to British Standard 82303 and its generation is 2014, okay? Now, the clue is in the title, guidance, all right? So what it says in this document is that noise emission from hydraulic systems, including domestic hot and cold water services, refrigerant pipework, soil and waste pipes, is not to cause disturbance in normal use. Doesn't tell you very much. It then goes on to give you a little table, and it says during those activities and that time of day, so during the day and overnight, your levels of noise within your place of living should not exceed those dB levels that they've stated there. Now, if you think about the library and you think about various other sounds and noises that we've listened to so far, you can see that that's actually quite high. And the problem with this is that as our homes become more and more quiet, so we have triple glazing, we live in a very noisy capital, and the more our homes become more hermetically sealed, the more any noise that does come in from neighbors and from above and below and behind actually becomes louder. So you're more aware of it because everything else is quieter. So generally speaking, we would see this as quite vague recommendation at the end of the day. It's giving you some guidance, but it's not really saying very much practically. We then have the rules and regulations around Part E, which actually is giving you notes on how to provide resistance to the passage of sound within a building, okay? And what that says is that the enclosed structure needs to have this 15 kilogram per square meter of density in order to contain the sound, and that it needs to be enclosed, and that you also need to preferably insulated to get the best possible effects that you can. So in the little drawing on number 1 there, that is quite an unrealistic situation for a home at the end of the day. You would expect to see something like that, maybe a rainwater pipe in a car park. That would be a good example of that. In the second one, that might be a duct that's a stack, as an example, that's coming down in a duct, but through a bathroom or through a kitchen. The third one could be that very same stack that then passes through the bedroom and passes through the living room, and you're going to want that to be far more insulated than you are the other options, okay? So this is how we test in the UK. So all drainage products are tested if they claim to be acoustically optimized, okay? They are tested to see how much sound actually emanates from the system. So there is a little sketch there, and there's some dimensions. And the good thing about this is that there is a little drawing, and it is more stringent than any previous tests we've ever had in the UK. But to call it a defined installation assembly, where you've got on the right-hand side there 5.8 to 7.5, and down at the bottom you've got 0.1 to 0.2 meters. I know what I'd be doing if I was testing sound emanating from there. I would be going down to 5.8, absolutely, making it as short as possible, and I would also be going to the 0.2 meters at the bottom, so that I was giving my product the optimum chance. So there is a little bit of vagary there to start with. The really not so good thing about the way we test in the UK is that literally somebody pours water in at the top of that pipe. So it doesn't take into account pushing to flush, the flush emptying into the pan, that then going out. It only picks it up from when it starts dropping down the stack, okay? So very different. There are no rules to say how many times that pipe, that stack, has to be fixed back. So the more you fix it back, the firmer it's going to be, and it's going to be less wobbly, so there's going to be far less structural sound transmission going on. You can fix it as many times as you like. That's not a really realistic room, because they're measuring it in the incident room, which is the one on the left, and the room behind it on the right. You'd never have an exposed stack like that, you know, in your house. And it also doesn't tell you on the actual certificate of conformity at the end of it what fixing products have been used. So if I was submitting my pipes, I could go off and buy the most acoustically optimized brackets on the planet and use those, and it wouldn't show up in the test. So there are lots of loopholes here, okay? And at the end of the day, whilst it's good, we would advocate, use a realistic setup. So test in a realistic setup where you are replicating a real environment, and do that by using wash hand basins, by using toilets, and also by using concealed pipes, because that's what most of us have. And also, big one, measure from the noisiest part of the whole operation rather than the quietest. So measure from the flush and look at the overall amount of decibels generated. The most important thing that we would then advocate is, instead of just measuring in the room and the room behind it, Measure those two, yes, by all means, but measure the room directly below, and also measure the room diagonally below, because that gives you, if you're living in a flat, that gives you a perfect scenario of all the water moving around you potentially, and how that actually can have an impact on your position within that broad framework of things. And doing tests like that actually allows you to get some test results. Now, I will point out here that these test results, they are done under laboratory conditions. They're not done on site on a project, but they are laboratory tests tested under very specific conditions, but they will give you an indication of the amount along the top there in blue of the amount of build-up and insulation that you will need in the various rooms in order to be able to achieve a livable decibel level within your environment, okay? And you can see there that the rooms down the side, they differ according to the build-up that you've got at the front, but also where they are in relation to the actual incident room. So it's very important to look at this all in a very holistic way. And yes, you can get results, but they are laboratory results, okay? You can get tests done on site as well, but then it's very, very project specific. So how can you translate that now into actually using product that's going to help you achieve these ends that we've been talking about now? So one of the first things that you can do is you can lift the toilet up off the floor, and we'll have a look at a couple of decibel values about that to start with on one of the slides coming up. The next thing that you can do is you can use installation sets, which is the bottom left-hand one on the bottom row of the little tile. And basically what that does is it decouples the toilet, the back of the ceramic, which is very hard, from any potentially hard material like a tile or a mirror so you're separating the two surfaces to try and stop structural sound transmission going on there. The next thing you can look at is acoustically optimized bracketry. So you've got slightly spongy insides to the brackets that are going to hold all your drain pipes, so that absorbs any movement as the water might move through the pipe. You can also look at, down on the bottom right, acoustically optimized drainage products, which you can go and have a look at on our stand as well. Somebody will be there to take you through them. And there are now pans on the market that have an asymmetric bowl. So instead of the flush coming out the back and sort of dumping all the water in the toilet, which actually causes quite a lot of noise, it actually comes out the side, and it's a much more swirling, and it almost looks like a helter-skelter on the inside. So the actual flush process is a lot quieter. And then you can also use rim-free. So instead of the water shooting around a rim and actually creating quite a lot of noise, it can just slowly come out of its own accord and gently flush the toilet. Another thing you can do, we talked about lifting the pan off the floor. Now there's some interesting data around this. The middle section of that drawing, of that photograph, there are two pans. The bottom one is attached directly to the wall. It's lifted off the floor, but it's attached directly to the wall, and it's a solid wall, okay? Breeze block, concrete wall, brick wall, whatever. If you measure inside that room, the sound that you will note on your meter will be 56 decibels, okay? Now, by installing the installation set that I mentioned behind that, all you've done is the same wall, same toilet, you've moved it away from the wall, you can reduce it down to 44 decibel. Now, if you go a step further, and those are the two sections on either side of that, the one is decoupled in a complete wall. So we've created a wall out of load-bearing elements and basically fitted the frame within it. So it's not tied back to the back wall at all, and it's tied up to the slab and the slab below. And the one on the left, there's a duct, which is more traditional in this country to actually create a duct and have your sanitary ware hanging off the front of that. In both of those situations, if you do that, you can reduce it down to 30 decibels. So you've almost halved the noise that you hear in the bathroom by just doing those two very, very simple things, okay? And as a result, there is no doubt that the more decoupling you can do, the better it's going to be for your acoustic environment. Now, I've never ever come across a project that doesn't have an offset. There is always one lurking somewhere, and they can be very problematic. And if you start off at a base level of 0, and you have 45-degree offsets, which is traditional, you will be adding on 9 decibels to the noise levels within that room. If you are in a position to be able to reduce that offset down to 30, you'll reduce it down by 2 decibels, so you will only have 7. And if you are in a very nice position to be able to reduce it down to 15, you get it down to 5. So again, that's something else you can look to do, but you need to look to do that early on in the project, because afterwards it's too late. All the offsets are there and the rooms are built around them. So that's something to think about in advance. The other thing that you can do on plan is you can look to back kitchens and bathrooms together, so that you're using you're saving space because you combining all the pipe work in one area of the flat. But you don't really, in where that red line is, not only have you got the bathroom butting up against the living room, but it's somebody else's flat. So, you know, this is really not a good situation at all. So that's on plan. And then in elevation section, you can try stacking the areas that are going to be causing the noise. So the bathrooms and the kitchens, if you can stack them up above each other and not have a bathroom over a bedroom or a kitchen over a living room, that again, if you think about those things early on, that's a very good way forward. And of course, if you've gone through all this process of using optimized acoustic drainage, acoustic bracketry, you've lifted your toilet off the floor, everything's decoupled, and all of a sudden you go on site and they've managed to recouple everything just by being sloppy, it's money that's, you know, wasted at the end of the day. So it's a very much, acoustic projects are very much a holistic approach, and I would say by doing that you get the best results. So just to round off really, we've just produced, based on that government YouGov survey, we've just produced a new white paper which is available on our stand just next door, or you can download it at geberit.co.uk/acoustics. And if you're an architect's practice or an interior designer, we have 7 RIBA accredited CPDs to offer you. And they cover all sorts of things: drainage, water compliance, sensory well-being, all sorts of things, and of course acoustics in much more detail than this. And again, you can book one through the website there, or visit our stand and pick up a leaflet. So thank you very much for your attendance. I hope it was enjoyable, and if anybody's got any questions, I believe not obligatory. I hope you enjoyed it. Enjoy the rest of the show.